Okay, every time I record it. Okay, so today's topic is about geometry. Okay, not 3D geometry, just plain geometry, and we are going to discuss several problems one by one. Okay, and I'm beginning with the rectangles. Okay, those are the problems you probably are familiar. Some of them it's from the homework you did. You know, if you took my basic math class. Okay. Well, the first type of problem is about rectangles. Now, if you are given a rectangle, right, what you should know about rectangle? Rectangle. Okay. So this is called the length, and this is called the width. It's denoted by L and W. So perimeter, okay, is going to be 2L plus 2W. Okay. Area A is going to be L times W. Okay. Okay. And so that's what they have here, right? Now, what kind of problems we can ask? You know, later on, maybe we will look at some mixture of problems. Maybe we're talking about circles also, right? So I have the first problem here I'm going to talk about is, suppose I have a rectangle, okay, and has area, some area, okay? This can be, you know, any number, okay? So for example, some area like 27 square centimeters. And we also know that its length is 3 times its width. Okay, now what do we have to find out? We want to find out the perimeter. Okay, so how do you solve this type of problem? Step 1, you always draw the picture, okay? And you label, yeah, you know, denote the length by L, denote the width by W, okay? So you are given area, yeah, you want to find the perimeter, okay? So you write down the given information. A is going to be LW, right, equals 27 square centimeters, okay? So you're given this. Then that's the first step, right? Then you want to find out, also you are given information, L equals 3W. Now, when you show the work, you have to step by step show all the, this given away. You want to find out the perimeter, so it's 2L plus W, right? Okay, so from here, what you can do, okay? You just need to find out, because L is going to be 3W, right? So if you find the width, you can find the L. Now, how do you find the width? Well, L times, so you are given 2 equations here. LW equals 27 and L equals 3W. So those are not linear equations. One of them is not linear equation, but you can replace L by 3W, right? So yeah, so 3W equals 27. Then you get 3W squared equals 27, right? Then W squared equals 27 divided by 3, which is 9. Then you can solve for W. W must be 3. So once you find the width, you can find the length. Length is 3 times W, which is going to be 9. Then you can find the perimeter. Okay, perimeter is 3. Is going to, you know, L, right? L is going to be 9. Width is 3, right? So it's going to be 24. Okay, and don't forget put the unit here. So this is how do we do that? When you when you show the details, you have to write down, name the variables, draw the picture, name the variable. Okay, I always say that the answer is not that important. The important thing is you have to show all the details, and you write down what is given. So here's this is a given. Okay, and then you write down what you want to find out. All right, so this is about rectangle. Now, rectangle also have other type of problems. Okay, we usually ask. Okay, for example, right? For example, if I have a rectangle, this is a suppose the air length increased by certain percentage, and the width is decreased by certain percentage. Okay, and we want to know how much changing in the area. So if the length of a rectangle is increased by 20%, okay, and the width is decreased by 20%, okay? So my question is, by what percent the area is changed? Is the area changed? Now, some students will say, oh, based on my experience, maybe there's no change because why? And the length is increased by 20%, so the width decreased by 20%, so they always cancel out in some sense, right? Well, we don't know until we do the computation, okay? All right, again, draw the picture because we're talking about rectangle, so draw the picture. This is a L, this is W. The area is going to be L times W, right? So this is going to be changed to another one. The length is increased by 20%. The width is decreased by 20%, so it's a little bit longer here, L prime, yeah, right? Now, what is the relationship between L and L prime? The area is increased by 20%. Increased by 20% means the original area, the length, plus 0.2 L, which is 1.2 L, okay? So the length is 1.2 times the original length. The width is decreased by 20%, okay, minus 0.2 times W, which is going to be 0.8 W. So the new width is going to be 0.8 times the original width. Okay, so the area, the new area is L prime and W prime. So we're going to get 1.2 L times 0.8 W. Okay, let's compute it. Okay, 1.2, 0.8. All right, so it's going to be 0.96 LW. Okay. So what does that mean? We don't know the exact value of the length. We don't know the exact value of the original width, but it doesn't matter. Okay. But L times W is going to be the original area. So the new area is going to be 0.96 of the original area, right? So that means it's smaller than original. Original original is 8. You have to minus 0.04a, right? In order to get 0.968. So this is a decreased part. Okay, so decreased by 4%. So that we can say that the area is decreased by 4%. Now you did not know that until you do the computation, right? All right, so if you know how to do this problem, I'm going to ask you to do the next one. If the length of a rectangle is increased by 10%, okay? Now, you want to keep the same area. So question is, by what percent of the width is decreased so that the area remain unchanged, okay? So by what percent of the width is increased by what percent is okay, yes, the width increased, decreased, okay. Decreased so that the area remains unchanged. All right, so this is a little bit difficult problem. So I know this is a width, this is width and the length, right? And I know the length is increased, okay? Increased by 10%. That's going to be L plus 0.1 L. I can, if I increase the width, I will increase the area. So in order to keep the same area, I know I have to decrease the width. Questions, can you do this? Yeah, the width must be decreased. So let's say original is W minus X percent, right? So X percent. So I'm going to say X percent of W, right? So decreased by X percent. Okay, so let's find the X so that the area remains unchanged. Okay. So this is called the start problem. Okay. So how do you do that? Well, you don't know what is X, just figure it out, right? So the area here is LW. Area prime is going to be 1.1 L times, and that would be 1 minus X percent. X percent is X over 100 times W, okay? And, right, you know, if it's 2%, it'd be 0.01. If it's 0.02, right? So it's 10% will be 0.1, you know. So that's why I divide by 100. The percentage will be changed to decimal number. Okay, so it's 1.1 times 1 minus X to the 100, and LW still is going to be A. Okay, so that is, this is A, right? So you want to make sure the area is not changed, and 1.1 times 1 minus X 100 should be always equal 1. So then you say that the area is unchanged, right? So you have to use a calculator to solve this problem. Okay, let's try not to use a calculator at this moment. How do you solve this linear equation, right? Then I move X to the 100 and to the 1 minus 1.1, right? Yeah, switch it. So it's going to be 1.1 minus 1, 0.1. So I'm going to multiply both by 100. Okay, my answer here is 10 over 1.1. Okay, so X, yeah, what the percent? More than 10, less than 10%. Okay, less than 10%, almost 10%, almost 10%. Okay, so you have to solve this linear equation. This is a little bit difficult, okay? So 10 divided by 1.1 is about 9.09. Okay, that's 2 digits is enough, okay? So X is that means a percentage will be 9.9%, about 9%, not about 10%, okay? Then you, okay, it's not about 10%. This is a rectangle problem. All right, so here's another rectangle problem. Okay, this is a problem. We know that okay, so just solve system linear equations. Okay, so the length of a rectangle is 3 times the width. Okay, so if the perimeter is 96 meet? What is the area? What is the area of the rectangle? Okay. So let's draw the picture first. Always draw the picture. Okay. You mark it. What do you know? So this is the length. This is the width. We are given the following information. The length is going to be 3 times the width. Okay. And we also know that the perimeter L plus W divided by 2, multiplied by 2, that's going to be 96. We're given this information. What do we have to find out? We want to find the area, which is L times W, right? Okay. So here, you can solve these 2 linear equations. Okay. The first equation is L equals 3W, right? And second equation, L plus W, we can 96 divided by 2. 96 divided by 2 is the 48. Okay. Okay. Right? L times W. So from here you can solve for W because that's the first equation. Second equation, L is going to be 3W. So use the first equation, okay, to simplify the second equation, that would be 3W plus W equals 48, and 4W equals 48, W equals 12. Okay, if W is 12, then L is going to be 3W, 3 times 12, and 36. Okay, then finally the area is going to be LW. L is going to be 36 times 12. Okay, 36 times 12. Okay, let's double check again. Yes. Okay, so it's 432. Okay, don't forget the units. What units do we have? Meters and meters, square meters. Okay, so those are about rectangles. Okay, now we are going to talk about special right triangles and the Pythagorean theory. Okay, so we know the Pythagorean theory. Okay, the Pythagorean theory. Okay. Pythagorean theory says that c squared equals a squared plus b squared if it's a right triangle. Sounds simple, right? Now there is a special right triangle, okay, and it is going to be 30 degree here, and that's a 60 degree. All right. So the sum, this is a 90 degrees. So 30 degrees, 60 degree plus 90 degrees is going to be 180 degrees. Okay. This is a special triangle. Okay. Now we want to know what kind of relationship among. Okay. So what I'm going to do is I can duplicate another one and put it here. So what I get here is 30 degree, 60 degrees. Then I got a triangle with all the 3 angles are equal to 60 degrees. That becomes an right, yeah, equilateral triangle. For the equilateral triangle, if this is a C, here's A, right? Here's B. Then this will be A, that will be C, right? So clearly, you will see that A is going to be half of C, right? Because 2A is going to be C. They all should be equal. because all the three angles are equal to 60 degrees. Okay. And how about the B? Can we express B in terms of C? The answer is yes, because this is a place you apply the Pythagorean theory. Okay. And you can find the B. And here A is 1/2 of C square plus C plus B square equals C square, right? So B square equals C square minus 1/4 of C square, which is 3/4 C square. Okay. So B is going to be square root of 3/C square. But we have to be careful, you know, this is going to be square 3, square C square, and the square 4. Square 4 is 2. Okay, so we get this relationship. All right, for the special triangle, all right, for the special triangle, let me list all this. This is a C, this is A is 1/2 of C, and B is going to be square 3/2C. All right, so that's the relationship. Okay, my question is, can you, this is an equilateral triangle, okay? If this side is C and C, right, equilateral triangle, can you get the area? Okay, now this is actually the B, clear, right? The height is a B. And I know that B is the square 3/2C, right? So the area is going to be 1/2 of C times B. Since C is going to be square 3/2B, then you will get square 3/4B squared. Okay, so I wanted to memorize the area formula for the, this is a C, I'm sorry for that, C. Okay, I want to memorize this formula for the area of an equilateral triangle, and which is expressed in terms of the edge length. Okay, but we got that using the above special right triangle. Okay, so this is a right triangle. All right, so let's do something using special equilateral triangle. Okay, I have a parallelogram. Okay, this is a parallelogram. Okay, and I know this is 30 degree. If I know this side is 3, that side is 5. What is the area? All right, can you try this? Yeah, can you determine the other angle? Okay. All right, so the other angle will be 150 degree. Okay, let me redraw the picture. Okay, so this is the whole line. There's a quick way to do that. So this is 30 degree, right? And that will be that would be 150 degree, and that 150 degree is same as this one because those two lines are parallel. Okay. Now, how can I find the area parallelogram? And the area parallelogram is going to be the base times the height. Okay. I can do the following way. What I'm going to do is this 30 degree. I'm going to draw the line perpendicular to this side. This is a 5. If I know the height, you can solve the problem. Okay, because this is 30 degree. It's a right triangle. So h, this is 3, right? H is going to be half of 3. Okay. So once you get an h, then the area is going to be the base times the height. So 15/2. See that? You say square root 3. I don't have a square root 3 here. Okay. So for the parallel triangle, a parallelogram, if this is the base, if this is the h, the area is going to be times h. Right. All right, so this is how do we figure out area of parallelogram. Now another interesting problem is from the previous homework. Okay, we know that given a rectangle in the xy plane with vertices, okay, vertices 2 and 3, 2 and n minus n plus 3, and 2 n plus 2, 3, and 2n plus 2, n plus 3. Now, be careful about those points. So you have 4 points, and they form the rectangle. We want to find out, okay, if we know the area, if the area of this rectangle is 128 square centimeters or square units. Okay, then find the n. So you want to choose the n so that you get to this area. So first thing you have to do is draw the picture. 2 and 3. 2 and 3 is here. Okay, 2 and x minus 3, x plus 3. X plus 3 is a number larger than, so this somewhere here, 2 and 3 plus n, right? So actually you're going to draw the picture like this, okay? And that'll be 2n plus 2 and 3. That'll be 2n plus 2 and 3 plus n. Okay. So this is why yeah, you just plot, you don't know the value of n. So how do you know those are 2 points, right? First of all, 3, they both have a 3, right? So those 2 points are on the horizontal line, and the 2n is larger than 2, so this point must be on the right hand side. Okay. All right. So what do we get here? On this side, that'll be 2n. Other side from 3 to 3 plus is n. Okay. We know the area of this rectangle. The area is going to be 2n times n, which is 2n squared. That is given 128. Okay, so n squared equals 128 divided by 2, which is 64. So n is going to be 8. Okay. All right, so we are going to, next one, we're going to have talking about an equator triangle. Okay, so for the equator triangle, those are 2 points equal equivalent. Okay, that's a 1/3 place. Okay, so maybe you can mark it 1, 1, 1, right? And no, I don't know the size. We do not assume this one, but that's equal points. Okay, the equal distance. So what I'm going to do is I connect those points. So I get right hexagon. Okay, so this is the right hexagon. All right, so this right hexagon has an area. Yeah, A, let's use A and B, C. Okay. If the area of the right hexagon is going to be 10 square centimeters, what is the area of the triangle ABC? And this is an equal regular triangle, okay? Yeah, okay. How do you solve this problem? How do they relate, right? This triangle we're considering here, right? How the triangle is related to hexagon? Okay. All right, so the triangle, okay, let's look at the hexagon. For in a hexagon, right? Hexagon actually, if you connect all the lines, the hexagon consists of identical equilateral triangles. Okay, so the area of the one equilateral triangle is going to be 1/6 of the area of the hexagon. Okay, and this triangle is the same as the triangle ABC. Okay, so those two triangles are actually identical. Right, so therefore the area of the triangle ABC is going to be 10/6, which is 5/3 square centimeters. Okay. Right, so let's do the one problem here. I give you a right hexagon. If the edge length A equals square of 3, okay. Okay, this is a right hexagon. Okay. With edge length A equals square 3 unit. Okay. Find the area of the hexagon. Can you quickly write? Hello? Can you do that? Okay. Well, it's not that complicated. If you pay attention to the last problem we discussed. Okay. Why? Because first of all, right hexagon consists of 6 identical equilateral triangles. And for each equilateral triangle, what is the area? The area is going to be square 3 over 4 times a square. Okay, right? Okay. So it's a square 3 over 4, and the square 3 square is going to be 3 over 4 square 3. So the area of the hexagon is 6 times that. Okay. So that is going to be 9 over 2 square 3. Got it? And the square units. Not 18. Where's 18 from? All right. All right, now we're gradually talking about the good circles. Okay. So my next question is, if I see give a picture like that, this is a rectangle, and this is a semicircle. Okay. Attach the semicircle. Okay. And I know the information here. Okay. That's going to be 13. That's 12. Find the area of the circle. Yeah, sorry. Well, and plus the rectangle. Okay. All right, so look at the picture. This consists of the semicircle, right, and the rectangle, right? All you need to do is to find this this side. Okay, so this side is going by the Pythagorean theory is going to be 13 square minus 12 square, 169 and 144. That's going to be 25, so which is 5. Okay, so that is the edge length, the width of the rectangle, right? So the radius of this rectangle is going to be 5 or 2. The radius of this semicircle. So the area of the semicircle is going to be, right, 1/2 the area of the radius, the pi times the radius square. Okay. So the answer here is going to be 25 and 8 divided by 8 pi. Okay, so the total area is the area of the semicircle, 25 over 8 pi plus 8 times 12 is 5, which is 60. Okay. Okay, I'm asking the total area. What is the area of the semicircle and the rectangle together? Okay. So we just add the area together, right? Find the radius of semicircle. Now, what is the important property for the circles we want to know? Now, given circle, let's talk about circle, right? What do you remember is the radius, right? The radius, the relation between the radius and the area and the circumference. The circumference, C is going to be 2 pi r, right? Area is going to be pi r squared. Everybody knows that. Okay. If you are given the circle. Another important property probably you don't know. If you have 2 points, okay, another point, this is A and B and C, okay, I draw this, okay. So if the angle at C is 90 degrees, if and only if, okay, if only if AB is the diameter. What do you mean if and only if? So if C is 90 degree, then it's a right triangle. If it's a right triangle, then AB, this must be the diameter, okay? And conversely, if it's diameter, then C should be, the angle at C is going to be 90 degrees. Okay, this is a very important property we should know, okay? So for example, okay, let's find an interesting problem, right? So for example, if we have a circle, okay, we're given A, B, and C and D. Okay, I draw this. Okay, so what I got here is I measured 24, and here's 10. I also know that the angle here is 90 degrees. Okay, so we know that this is going to be 90 degrees. Okay, what do we have to find out? We have to find out the area of the circle. Can you do that? Yeah. Find the area of the circle. Now, to find the area of the circle, you just need to find the radius. But okay, so this is a difficult problem. I have to say that. Right? It involves the above properties for the circles. Also involves Pythagorean theory. Okay. So what you have to do is you draw the line between B and D. And I claim B and D is a diameter. Okay. So step by step. Okay. Using the triangle ABD, so right, since this angle is 90 degrees, so it implies BD is the diameter, okay, of the circle. If BD is diameter of the circle, then this implies the angle at point C is getting 90 degrees, okay, by the above theorem again. Okay, so you actually get two right triangles, okay, share the same hypotenuse. Then can you figure out the diameter? So BD by the Pythagorean theory is 10 square plus 24 square. Okay, 10 square plus 24 square, that is going to be 13 times 2 is 26 squares. Okay. Now you say, how do you know that? Do computation quickly. But I know 5 square plus 12 square equals 13 square. Okay, if both are multiplied by 4. All right, so BD is going to be 26. So the radius, this is the diameter. So the radius is going to be 26 divided by 2 is going to be 13. Then you find the area, right? The area is going to be pi r square, and the pi 13 square 169 pi. Okay. All right, so let's talk about next problem. All right, so I'm going to draw the circle. Inside circle, I draw a rectangle. Okay. Now, what I'm going to do? We are given the information, the rectangle, this is L, this is W. So L equals, we just assume that 8, W is going to be 6. Okay. My first question is, what is the radius of the circle? Can you find out? Then I do the next problem. Next problem, I draw the circle here again. I still use the same L. Length is 8, W going to be 6. I choose the middle point. Choose the middle point. I connect them, okay? And yeah, this is the middle point, okay? And so A, B, C, D, and A, B, C, D are the middle point on each side. Okay. And this is okay. So find so what do you get? You get called a rhombus, right? Find the perimeter and the area of rhombus. Okay. Okay, let's do this problem step by step. So you got someone give me the radius. Sorry. Okay. So what is the radius of the circle? Okay. So let's go back to this picture. Okay. So this is a picture. So the radius, this one, it's r, right? So in order to find r, you have to draw the addition lines. So you get a right triangle. For this right triangle, this side is 4. So this side is 3. So I is going to be 5. We answered the first question. For the second question, we needed to know what is this edge length, right? You can find out by the Pythagorean theory, but this is obvious. How do you do that? You draw the let's draw the see. We have to draw a addition line here, right? You draw the design. You get a rectangle. This rectangle has two equal diagonals. So that's why A is nothing but the radius. A is actually the edge length is going to be the radius. Okay, the radius we already know it's going to be 5. So the perimeter is going to be 5 times 4. It's 4 edges there. That's 20. Now, what is the area? Area, that's even better. It's 4 times the area of each triangle, right? Each triangle is going to be 1/2. This side is 3, this side is 4, right? So 3 times 4. Okay, 4 plus 6, it's 10. Okay. Now, here's a question. Yeah, almost done, right? So if I draw a rectangle, okay, this is 8, that's going to be 6. Instead of, this is middle point. And on this diagonal, right, diameter, I connect this two. Okay. This is a diameter. Okay. Now my question is, what is the edge length of this ramp? Right. So this is what we call the B, but that's B is not different. Anyone has an answer? How is the area of 10? Can you figure it out? Yeah, people get the area. Okay. Area of 10 is going to be this rhombus is divided into 4 triangles. Each triangle has an area. There are 4 right triangles. Okay, each triangle in the above picture is going to be 3 times 4 divided by 2, 6. Yeah, 4 times 6 is, sorry, it's plus. 4 times 6 is going to be 24. Sorry, I'm sorry. It's 24. Okay. Yeah, 24. You know, when I was right, yeah, I wrote multiplication, but then I saw it's plus. It's 4 times, not 4 plus. Okay, I should write the multiplication plus bigger. Okay, product bigger. Now here, let's do this problem. Okay, the last problem. What is the age of this new age length of this new numbers? Okay, so how do you find this? Okay, to find this, you need a, what do you need? You need a, no, this is a right triangle, right? So this is obvious. Okay, okay, this side is going to be, yeah, the width is 6, right? So this is 3. And we already know the edge length, right? This is the radius. This radius is going to be 5. Okay, so B is going to be square root of 3 square plus 5 square. Okay, so that is going to be 9 plus 25. That's a 30 square, 34. Okay, that is a square 30. Got it? Yes. Okay. So, yeah, that's all about today's lesson. Okay, it's all about today's lesson. Now,